Okay, so we finally come into the exercises at the back of the Python for Biologists book. So there's basically there are just two exercises at the back of the book, but I've included an additional one or two just so that you can see some other basic things that I think you will want to do as a bioinformaticist. So the first exercise, exercise one, is about, again, processing a DNA file, but here we get to implement using the for loop. So the instructions are, there's a file called input.txt that contains a number of DNA sequences, but they are separated one per line. Each sequence, however, starts with the same 14 base pair fragment. Now, again, we see the same here, so they're talking about repetition, and that kind of gives us a clue that we're going to be using a loop. And this 14 base pair segment is a sequence adapter that should have been removed. So it's our duty to trim the adapter off these lines and then create a new file to which we will print these trimmed adapter sequences, one per line, and then also to then print the length of each of the sequences to our screen. So I'm just going to go straight to the solution. Remember, we use, for best practice, we use the with open instead of just the open, so that we don't have to remember to close the file that we're opening, so our input files or our output file. And again, this section over here obviously will change. For the GitHub channel, I will remove that because it will be running from it will be taking the input data from the GitHub channel. But if you want to add the script to your computer, you're going to have to obviously change the path to wherever your input file is. So we're using the with open, and we're opening this particular file and we're storing it in this variable name called input file. And as I explained when we did the previous chapter, where we did reading and writing files, that instead of just writing with open over and over again, I separated by a comma and I just opened the file that I'm going to write to as well. And then I just use this escape character so that it looks a little bit more readable and neat, because I can add this line or this section to a new line. But this is actually one line. So yeah, you can do that as well. So now, again, as I said, with the for loop, you could see it as something that both reads the file in and reads it in on a line-by-line basis. So you don't use, remember in the previous section, we had to, after we opened it, we had to say, for example, we would have had to say, open file is equal to input file.read, or .read line, or .read lines, depending on what you want to do. But when we use a for loop, we don't have to use any of the .read methods. So we go straight and we read for line in input file, right? So it's going to read this input file. I just want to show you what that file looks like. And that's something that you should always do. I would advise you to always check what your input file looks like. So hopefully you can see this, and you can see your input file is there line by line. And as I said, there's the same adapter sequence ahead of each of these sequences, and that's the part that they want you to remove. Okay, so I'm going to go back to sharing this file. So we're looping now through that file on a line-by-line basis, but what we're doing is, this is something I always do, we're taking this line, so remember we're on line 1 now, and we're going line.strip, so we're stripping all blank characters from there, and then we are only going to read each line from position number 14, which is actually your nucleotide 15, because remember, indexing starts at 0, so 0 to 13 are actually 14 nucleotides, which are your 14 adapter sequences that needed to be trimmed. So if we put in here 14, it's actually reading from the 15th nucleotide, which is actually the nucleotides that we want. Okay, so I'm then storing this in something called new line, and then remember, if you print this, it's all fine. I can show print new line. Just gonna do that quickly. If I print this, it's fine. They all print on a new line, but the print statement automatically introduces a new line. But if I'm going to print this as is to a script, sorry, to a file, then it's not going to be printing out that sequence with a new line. So it's going to basically print all of these together next to each other, and that's not what we want. So I'm taking this new line now, which contains my proper nucleotide sequence that I want, and then I'm just adding a new line to that, and then I intuitively call this outline so that I now know that this is the line that I'm going to print. Okay, I'm not going to print that to stand it out now, but then I go to my out file, and because I want to now instruct the program to write out my outline, I then say out file, which is this file called adapted trim sequences. I named it myself. You can obviously name it whatever you want. And of course, if you don't want to print it to your desktop, you can change this file path. So this file is already open for writing. And I'm calling the variable name of the file, and I say write now this outline to this file. And it's going to do, when it gets to the end, and then it's going to print the length of that file, because the instruction is also to print the length of each sequence to the screen. But once it gets here, it's going to ask, am I done? I'm in a for loop. And it's going to see, no, I'm not done. So if you can imagine, this is the DNA file. I'm not done because there are more lines. So it's going to go back up to the second line in that file, do the same, trim off the blank spaces, take nucleotide number 15 and above, add a new line to it, and then write it to the file, and then print the length of that. And then it's going to see, I'm still not done. And it's going to go to line 3 in the file, and so it goes on until it gets to the last one, and then it exits the loop. Okay, so you should print these ones like that to the file, and then if I then look at, oops, that's the wrong one. Okay, so if I now look at my desktop over here, I would see that this file is there. And I'm not sure if you can see this, so let me just do a new share of that file. So you should be able to see that this file has trimmed all of has none of the nucleotide sequences ahead, and they're all different sizes. So this has worked properly. So the input.txt file all starts with this part, and then you can see the name up there, but the adapter trimmed has all of that removed.